Implicit differentiation. What we have in this section, we're still learning how to differentiate functions. And what happens is, in previous sections, we learned how if y equals something's given, how do you find the derivative for that? And I'm going to explain what this means, even the name where it came from, in a minute after I do some introductions. So recall that when we say y prime, like the derivative of y, you can write it as dy dx. That's another way to write it for the function y equals f of x. For the function y equals fx. So when we found the derivative of x, we told you it's 1. Why? Because you're finding the derivative of the function is x, with respect to x. That's why it's 1. Okay, so the derivative of x is 1 because of this. And recall the chain rule. We need that all the time. That chain rule says if y equals u to the m, then y prime is m u to the m minus 1 times u prime. Or some people write it as m u to the m minus 1 times du dx. That's the chain rule. So if we are asked to find the derivative of x squared, or even cube if you like to make it. So this is the same as like that, the derivative of x cubed. By the chain rule, you bring the 3 down, subtract 1 from the 3, times the derivative of the u. This is our u, the highlighted part, times the derivative of x with respect to x. That gives us 3x squared times 1. So it's 3x squared. But if we are asked to find, just next to it, y cubed derivative, unlike x cubed, what do we get? Well, the same procedure. You bring the 3 down, subtract 1, times the derivative of the u, which is y in this case, dy dx. That gives us 3y squared dy dx. See, that's the difference. So in general, so just as a summary, derivative of x is 1 and derivative of y is y prime. Try this one. For the first one, we have bring the 5 down, y to the 4 times y prime. And you just leave it like that. Or you can write it like 5y to the 4th y prime. How about the next one? I see a product of two functions, so that reminds me of the product rule. To recall, the product rule says if you have u dot v, or u times v, the derivative for that is u prime v plus uv prime. So here is x squared derivative times y cubed plus x squared times the derivative of y cubed. That gives us 2x y cubed plus x squared. Derivative of y cubed is 3y squared y prime. As a final answer, 2x y cubed plus 3x squared y prime. So now we go ahead to try this one. Product rule again. So x cubed derivative times y squared plus x cubed times the derivative of y squared. 3x squared y squared, x cubed times 2y prime. This stays the same. 2x cubed y prime. So from here to here we use product rule. We use product rule. So now, why do we call it implicit differentiation? Well, we were originally in the previous sections given, it was given y as explicitly as a function of x. And all we did, we found y prime. But in some cases, some equations are more complicated. More complicated to solve for y. To obtain its derivative. So that's why we go implicitly and differentiate the whole equation implicitly. So if they ask us to find dy dx, which is y prime, for the equation x squared plus y squared equals 10, if we're asked to find the derivative for this, what we do, we differentiate the given equation, or the equation above, implicitly. Well, someone will say, wait, I can solve for y. Yes, you can. But as I said, some equations, they can, it can take a lot of time for you to solve for y if you are able. Like I'll show you an example where it's almost impossible to solve for y. That's why we have to go with differentiating the equation, like both sides, implicitly. Now, how do we differentiate this? Basically, we take the derivative for each one of them. The derivative of x squared is 2x. The derivative of y squared, 2y prime. Derivative of 10 is 0. We are asked to find y prime. Divide everything by 2. You get x plus y prime equals to 0. I need to solve for y prime. We subtract x on both sides and then divide by y. So now, look at this equation. It's almost impossible to solve for y. That's why what we can do to find y prime, we're going to differentiate both sides implicitly. Differentiate both sides. So we rewrite it like so. Derivative of the first one, derivative of the second one, derivative of this one, and derivative of this one. What do we get? What's the derivative of the first one? We can use, or we can find the derivative of this one by using product rule, as we did in the previous examples. Product rule says you find the derivative of the first one times the second plus the first one times the derivative of the second plus derivative of this one times the second plus x squared times the derivative of the second. Derivative of y is y prime. Derivative of 21 is 0. Again, derivative of y squared 2y y prime x. Derivative of x squared is 1. If x is 1. Derivative of x squared is 2x. Derivative of y cubed is 3y y squared y prime, and bring the x squared down, equals y prime. Now these are the terms containing y prime. So what are we going to be doing? Keep the non-y prime terms on this side. Subtract 2y y prime x and subtract 3y squared y prime x squared. Why did I do this? Because I want to solve for y prime. That's what the question is asking me to do. So nothing can be done on the left hand side, but the right hand side you can take a y prime out. 1 minus 2yx minus 3y squared y prime, x squared. So I factored y prime out. Then y prime is y squared plus 2xy cubed over 1 minus 2xy. 3x squared y squared. Find y prime or dy dx for the equation x cubed plus 3xy equals 6y squared. Okay, so now we may go over this. What do we have in this one? We are going to differentiate both sides implicitly to get the derivative of x cubed, derivative of 3xy, and derivative of 6y squared. The derivative of x cubed is 3x squared. Take the 3 out here. We use the product rule. Derivative of x times y plus x times the derivative of y. And take the 6 out. Keep this as is. 3. Derivative of x is 1, so that gives me y, plus x. Derivative of y is y prime. Now what's the derivative of y squared is 2y y prime. We may divide everything by 3. You get x squared plus 3 is gone. Divide the 6 by 3, you get 2. 2 times 2 is 4. Again, we want the terms containing y prime on one side. So keep x squared plus y as is. 4y y prime, subtract xy prime on both sides. X squared plus y equals, take a y prime out, That will leave 4y minus x. Then what is y prime? X squared plus y over 4y minus x. That's what y prime is. To apply this to more of a business stuff, let's say we're given the total revenue function as r of x given as 50x minus 0.5x squared. And we are given the total cost function c of x equals 4x plus 10. They want us to find rates of change or changes of total revenue, cost, and profit with respect to time when x is 30 and dx dt is also given as 20 units per day. So what they are asking us to find out, they want us to find the rates of change for total revenue. So they want us to find dr, total revenue, that's what the change, and profit with respect to time. So dt, what is that going to be? They're asking for also not just the revenue, but the cost with respect to time, and the profit, dp dt. So let's take them one at a time. We are given r of x as 50x minus 0.5x squared. We need to find dr dt. So let's see how we do that. We differentiate both sides, diff both sides with respect to t. What do we get? dr dt equals 50. Now remember, I'm not differentiating with respect to x. We don't have something dx, no dy dx. Here we're differentiating with respect to the time t. Means the derivative of x is not 1 anymore. It's dx dt. dx dt minus, keep the 0.5 as is, bring the 2 down, x times by the chain rule, again dx dt, because this x here is our u, du dx or du dt. Let me rewrite this in a more simplified form. 50 dx dt minus 2 times a half, because 0.5 is a half, that's an x, dx dt. But if you look back at the problem, they want us to find this, calculate this, find the value of it. They give us more information. What did they give us? They give us the value of dx dt, which is 20, and they give us the value for x, which is 30 times 20. That would give us 1,000 minus 600. So that gives us $400 per day. That's the change in the time. Change of the revenue with respect to time. Now, you should try to find dc dt on your own, which should be easier than this one, than we just did. So again, from the problem, c of x was given as 4x plus 10. We are interested to find, or asked to find, dc dt. Differentiate both sides with respect to t. Keep the 4 as is. The derivative of x is dx dt plus 0, because the derivative of a constant is 0. And from the given information, they give me dx dt 20. So that gives us $80 per day. The last part was, what's dp dt? Well, to find dp dt, we need to have a function for the profit. What is the profit? The profit, we define it from using previous sections as r of x minus c of x. Now we can differentiate both sides with respect to t. So dp dt, dr dt, dc dt. The good thing about this, you could substitute the given r in and the given c in and then differentiate it. But notice how I did it. It's easier way this way, provided that the past two parts of this problem were done correctly. If not, then you will get a wrong answer for the dp dt. So dr dt, we found it was $400, and dc dt, we just found it. It's $80. And that would give us $320 per day.